start now. Alright, so today we're going to be talking about solving quadratic equations by factoring and taking square roots. So what does that all mean? There we go, my pad was not turning on, it was stressing me out. So essentially we're going to use factoring methods to solve for x here. So a lot of this hinges on your ability to factor before you can find solutions. So in this class we have learned AC method instead of x factor. It's the same thing, it's just a different kind of way that you do it. You write it a little bit differently. But I'm going to do AC method. I just forgot to change it on the notes before I sent it to print, so don't mind that. Alright, step 1 is we're going to find the GCF and solve for x using the GCF. So, what is the GCF of letter A there? 7x. Remember, you got to take out the x as well. So that's going to become 7 times x minus 3 equals 0. Now, that would be fully factored form. So what you would then do from here is to set each of these factors equal to 0. And then we're going to solve for x. Divide by 7 on both sides. We get x equals 0. Over here we're going to add 3 to both sides, and we get x equals 3. So your two solutions are going to be 0 and 3. So that means if you plugged in 0 or 3 for x, you're going to get a true statement. Any questions about that? Okay. Over here, in order to find a GCF, we're going to get the 9x to the other side by adding it over. We're going to end up with 6x squared plus 9x equals 0. And then we're going to take out a GCF on the left. What would the GCF be here? 3x. We're going to take out a 3x, which leaves me with 2x plus 3 equals 0. We're then going to set each of these equal to 0 separately. So we got 3x equals 0 and 2x plus 3 equals 0. And then you're going to solve those two solutions independently. Now if you're wondering why am I setting these equal to 0, that's based on the zero product property, which states that if the product of two things is 0, one of those items has to be 0 at all times. So that's why we're able to do this. So in this side I divide both sides by 3. 0 divided by 3 is 0. And over here I start by subtracting 3 on both sides. That gives me x equals negative 3 over 2. So my two solutions are negative 3 over 2 and 0. Does it matter the order you put them in? No. Is that what you're going to ask?
No.
Oh, go ahead.
Why do you separate the 3x into 0 and 2x plus 3?
So the zero product property is what it's called, and that states that if you have the product of two things, the product of 3x and 2x plus 3, you can set each of these equal to 0 to find the values for which x could be, whatever it could be given that it's 0. Any other questions? Okay. So now we're going to solve using factoring methods for quadratics. Step 1 to factor a quadratic or a trinomial is to make sure that the a term is 1. So when it's negative, you want to factor out a negative 1 first and foremost. And when you take out a negative 1, it's going to change the signs of everything inside the parentheses. Now from here, we're going to factor what's inside the parentheses using normal factoring methods. We're looking for factors of negative 32 that add up to negative 14. Any ideas? 8 and 4 would work if it was 12. So what did you say? 16 and? Negative 16 and positive 2 would work, right? Because those would multiply to give me negative 32, but add up to negative 14, right?
Yes.
So now we can set each of these products equal to 0, these three products. So negative 1 equals 0, x minus 16 equals 0, and x plus 2 equals 0. The first solution is going to get rejected because this doesn't even make any sense, right? So you reject that one. This one I'm able to solve for x, and it tells me x is equal to 16, because I add 16 to both sides. And lastly, if I subtract 2 on both sides, I get x equals -2. So my solution set is -2 comma 16. So if you were to graph this in Desmos or a graphing calculator or by hand, the two values for which we cross the x-axis will be -2 and 16. That's where we cross the x-axis. That's what we're finding. Okay? So as for the next one, step 1 is to see if we have a GCF. Is there any number that these numbers are all divisible by that I can pull out? Good, I can take out a 4. That means every single term is going to be divided by 4. Once I get here, I verify that my coefficient in front of my x squared is 1, which it is, which means I can go ahead and factor it the normal way. I'm looking for factors of 9 that add up to what? -6, which would be what two numbers? -3 and -3. I can then set all of these equal to 0. What's going to happen with the first one? Yeah, it's not possible. This one becomes x equals +3. This is also x equals. Good. So my one and only solution is x equals 3. Now, you're going to learn in the future of this class what it means to get the same solution twice, how it affects the graph. But for today, and for, when you're writing the solution, you don't need to write that 3 twice. You only have to write it once in the set. Okay? All right. Now we're going to move on to some that sometimes you have to move around before you can factor. Okay? So this one, for example, is it in standard form right now? No. So we're going to have to do what with this 12? Yeah, we're going to have to add it over. And not only that, we're going to have to rearrange the other terms as well. So this is going to become 2x squared plus 11x plus 12 equals 0, because I had to get it into standard form. Now from here, we're going to identify if we have a GCF or not. What do you guys think? No. So when we don't have a GCF, we're going to use AC method. That's where you multiply the A by the C. That's going to be 24. So what are factors of 24 that add up to 11? 8 and 3. And then in addition to that, when we multiply by 2, we need to counteract that by doing? Dividing. So this becomes x plus 4, and this becomes 2x plus 3, right? Good. Now you would stop here if we were just factoring, but remember our goal is to solve, so we're going to set each of these equal to 0. Over here, that's going to give me x equals -4. Over here, that's going to give me x equals -3/2. So I just solved that two-step equation. Subtract 3, divide by 2. My expectation is, if you're here, you know how to solve a two-step equation, right? So everybody's good with that? All right. Next one over here, we're going to start by getting it into standard form. What is step 1 to do that? Rearrange and add the 20x over. Very good. So I'm going to add that over. And as I do that, I'm going to write it into standard form. Like this. Now my goal now is to identify if I have a GCF. What do you guys think? Yeah. We can take out a 4 actually. So if we take out a 4, we're left with x squared plus 5x minus 14 equals 0. And now that we have a coefficient of 1, we can factor it. We don't have to use the AC method. So we're looking for factors of -24 that add up to +5. What do you guys think? Good. 7 and -2. Since we didn't use the AC method, we don't need to divide. Yes?
Why are we trying to find a thing by -24? What are you talking about there?
24? Oh, well, I assume you guys know I meant 14, right?
Oh,
Sorry. Sorry to confuse you. um, so yeah, negative 14. Negative 14. Okay. Is everybody good with where we're at right now?
Yeah.
Okay. We don't need to divide by anything, right? Because I didn't use the AC method. So now I can just set them equal to 0. And then you can solve. Rejected, x equals negative 7, and x equals 2. So if you want to write it in solution set format, that's negative 7 and 2. Sorry, too low. There you go. Alright, do you guys feel good about the trinomial factoring?
Yes.
Yeah.
Alright, now we're going to learn about square root method. Okay? So how do we use square root method? Now you've already learned this is the difference of squares, which you could factor into 5x minus 7 and 5x plus 7. But we're going to learn another method today on how to do that. Now you might be wondering, how do I know when to use this method? So let me identify that for you. When you have an x squared and everything else is just numbers, that's when you know you're going to use this method. If you notice the last one, see how there's also an x without an exponent on it, like an x with a 1? That's when you're going to use trinomial factoring. But here, when there's no plain x, you're going to use this other method. So your goal with this method, if you do it the factoring by the way we learned before, that works too, but I'm going to show you an alternative. So you're going to start by isolating the x squared. So we get 25x squared equals 49. And then your goal, again, like I said, is to isolate the x squared. So I'm going to divide by 25. And I'm left with x squared is equal to 49 over 25. So in order to reverse a square in math, because we want to solve for x, does anyone know what we do?
Take the square root of both.
Take the square root. A square and a square root reverse each other. So in order to get rid of this x squared, I'm going to take the square root. But what I do to one side, I have to do to the
Other side.
to keep balance in the equation. So this is going to give me x equals. Now here's something very important that a lot of people forget. When you're solving an equation for x and you take the square root, you need to put in a plus or minus. And I'll explain why you have to do that in a second. But for now, what is the square root of 49?
7.
What's the square root of 25?
4.
So we get plus or minus 7 over 5. Now what does that mean? That means you have a positive version of 7 over 5 and a negative version. Now let me explain what that plus or minus means, why we do it when we take square root. What is negative 4 times negative 4? What is 4 times 4? Plus or minus, because if I were to square either of these numbers, would they still come out to be the same result? Yes, that's why we throw in a plus or minus. Okay? Any questions before we move on to B? Alright, letter B.
So
I have,
the answer, it's negative and a positive.
yes, there's two of them.
For a test, would you set them just on top of each other?
Yes, good question. For a test, if you want to put this as your answer, that's totally fine. The plus or minus. You can put them in brackets too. I would accept this, I would accept this, or I would accept this as well. That means multiple choice could be any of those, so just be aware of that. Yep, any of those is fine. Alright. Next one, we have an x squared and just numbers, so we want to isolate the x squared, right? To isolate the x squared, I'm going to subtract 13 on both sides. That gives me x squared is equal to negative 12, correct? To get rid of a square, I take the square root of both sides. That gives me x equals plus or minus. Now here's a problem. Taking a square root of a negative, what happens when we do that?
Error.
It would give us an error, but we can also put in an I. So you can rewrite it as I times the positive square root of 12. So really, here's the gist of it, the simplest way to think about it. Anytime that you're taking a square root of a negative number, you're going to make it a positive and take an I out. Okay, that's really all you need to know about this. Alright, if you didn't understand why, if you didn't like that lesson, that's the rundown, okay, for that part. So now you need to simplify the square root of 12. So isn't it true that I can rewrite the square root of 12 as the square root of 4 times the square root of 3? What is the square root of 4?
2.
Two.
So I get plus or minus 2i radical 3 as my answers. And if you want to write them as two separate answers, that's totally fine. If you want to leave it as plus or minus, that's fine too. I mostly will leave it as plus or minus on the keys just because it's the fastest way I can get through making your keys. But just be aware of all the different options. Does anyone have any questions about B before we move on to C? Okay, letter C. We have an x squared in just numbers, so we need to isolate the x squared. We'll start by adding 12 to both sides, and then dividing by, which gives me x squared equals 6. How do I reverse a square in math? Take the,
Square root.
that's going to give me x equals plus or minus square root of 6. Unfortunately, the square root of 6 does not break down. It breaks down into 2 and 3, so there's no perfect square, so that's as simplified as it can go. So you're going to leave it like that. Okay? If your question ever asks for an exact result, by the way, and if the answer comes out to be a square root, you're going to leave it as a square root. Never give the decimal answer unless it asks for it, okay? So that's just like a quick tip on SAT, ACT, everything.
So wait, that's not the exact result, right?
This is the exact result. The approximate result would be if I put this in the calculator and got an approximate like decimal for it. Yeah, so if they said like round your answer to the nearest tenth, that's where you're going to hit the square root button on the calculator and give them a decimal.
Okay.
Okay. And last one, D, we're going to start by adding 1 to both sides. How do we get rid of that denominator?
The reciprocal.
Yeah, you can multiply by the reciprocal. That will work. So 3 over negative 2 on both sides. These cancel, these cancel. X squared equals, that would give me negative 27.
Yeah.
Um,
Oh my.
Calculator will do it for you if you want, yeah. You can just do 18 times 3 divided by negative 2, and it will give you 27.
Why?
How did I do it?
No, why are we multiplying? If it's times, if you're multiplying x times square root of negative 2 over 3, why are we multiplying?
I don't understand your question.
Because over there, usually you would divide.
Maybe here, maybe this will clear it up for you. Maybe you learned it by multiplying both sides by 3 to get rid of the division, and you get this. And then you then divide by the negative 2,
Because you have to cancel out the negatives, so it's like 3x and then negative 2.
and it gives you that.
Multiplying as a division.
Does this way make more sense, maybe?
And this is fine. I got it. I got it now. I got it.
Are you sure?
Yeah.
Okay. So how would I solve it from here? I would take the,
Square root.
that's x equals
9 and 3.
plus or minus, very good. I, remember, because it's negative, radical 9 times radical 3, which reduces to x equals plus or minus 3i radical 3.
Oh. Oh. Okay, I was really confused.
So that's just simplifying the square root.
Gotcha.
Yeah, those i's are being created.
All you have to worry about is if it's negative, put an I. If it's not, then don't. I know you guys don't like the i's, but it's okay.